Hello friends, welcome you to Curiosity class. I'm Sunny Shah and today in this video lecture I'm going to talk about a topic of engineering mathematics, that is numerical solution of equation. So as we have studied earlier, to find out the roots of polynomial equation and the solution of linear equations, simultaneous equation and some other equations, there are some limitation in analytical method. We can't find out the roots of higher order polynomial equations. So in order to find out the value of such equations, we use a new method is developed. We use a new method. That method is numerical method, and in this video I'm going to talk about the numerical method of finding the polynomial equation, algebraic polynomial equation. And the method, there are several methods of finding. So in this particular video I'm going to talk about the bisection method. So let's see what is bisection method. So let fx equal to 0 be an polynomial equation. Now in this bisection method, what we do, we convert this equation into a two-dimensional curve equation. Let us graph this equation. In order to understanding, we are converting into a two-dimensional curve. Let's plot it, this equation. Let this be the point at which the root is. This is because at the curve where it passes the x-axis will be the root, because at that point the value of y is 0, that is this one is 0. So this is the root. So this be the x0. Now in this equation, what we approximate by trial error method. We approximate to point around the root. Let a and b be 2 point. Let this one be a and this one be b, and the approximation is done in such a way that f is either positive, fa and fb are opposite in sign. Now here fa is negative, fb is positive, so these are opposite in signs. Now in order to take the first approximation, what we do, let x1 be the first approximation of the root of the equation. What we do, we take the average of these 2 points. This is the average. Now let's visualize it properly in the graph. Now if it is a and b, this, so this will be the first approximation x1. This is first approximation because b is far from a, that means x0. A is also far from x0, but x1 is nearer to x0, that is the root. So this is the first approximation. So we find out the first approximation, that is x1. Now we will check fx1 whether it is positive or negative. In this problem it is positive, as we can see here, it is positive. That means the value of y is, that means positive is because for at x1 the value of y is positive. Understand? So now for the second approximation, let x2 be the second approximation of value. What we will see, as it is positive, at fx1 is positive, we will take, so for the approximation we need 2 value so that we can take the average. So as fx1 is positive, so we need another value, either a or b, for the calculation of next approximation. So if fx1 is positive, we will see which value of f, a or b, is negative. So we can see that the value of fa is negative, so we will take a for the calculation of next approximation, at a plus x1 divided by 2. So this is the second approximation. Now thus what we will do, we will continue the procedure. Let x3 be the third approximation. Now this is x1, this is a, so the average will be in between these here. So you can see this the value is getting nearer to the point x0, that means nearer to the root. So x0, so this is x2, so this is giving a negative value. x0, this is giving a negative value of fx0, fx, sorry, this is x, this is not x0, it is x3, sorry, x2, x suffix 2, okay. So x2, so fx2 is negative from the graph. So we will find out for the third approximation x3, x2 is fixed. Now we will check out the nearest point whose fx is positive, as it is negative. So we can see that nearest point is x1 and whose fx1 is positive. So we will take x1 here and we will take the average. So this is the third approximation and it will be in between these two. So it is getting nearer and up to particular taking particular number of iteration, there is the number of approximation we are taking, the calculation is done. The value of x will be to some extent nearer to the original accurate value of the root of the equation. So thus we find out the root of the equation, that is a solution of the polynomial algebraic equation by the method of bisection. This is the method of bisection. In the next video we will take an example of this bisection method, and after that in another video we will find out the we will talk about other method of numerical solution of equation. So if you like this video, do share with your friends so that they can get the concept very easily, and do subscribe our channel. Thank you.